Okay, so going over the practice test. The majority of this test is factoring, with a few things kind of dispersed in. So before we go through this, first thing you should always look for. GCF. That's where you need to start. So as we're going through this on Friday, some people were missing the GCF. Always start at GCF. Then you have three other options. You have difference of squares. When do you use difference of squares? Perfect squares, two terms, and a subtraction sign in between them. Okay, you have to have all three of those qualifications. And then you have the x versus the super x. Okay, those are the four ways we've learned to factor. Remember, you can use a super x with anything. It doesn't just you don't have to use the x. But always look for GCF first. Any questions on that? Okay, so this first column literally just says factor completely. If I start with number 1 using GCF, is there one? Yes. What can I pull out? A 4. Leaving me with x squared minus 4. Okay, so I pulled out a GCF of 4, and I'm left with x squared minus 4. You need to then look at what's in the parentheses and see if it can be factored more. So, just in case you missed a GCF, always just make sure you check for GCF again, but can we use difference of squares or either the x or the super x? Difference of squares. There's two terms. There's a subtraction sign and both are perfect squares. What is the square root of x squared? X. What is the square root of 4? 2. One's plus, one's minus. So your final answer should be 4 and then x minus 2, x plus 2. If the parentheses are switched, that's fine. Okay, but you have to be able to recognize those. Number 2, if I start with GCF, is there one? No. And what would I use in this case? Okay, you can use a super x. I heard that first, so I'll use it. What else could you use? The regular x. The super x is nice, though, because it does give you the variable on top, so you don't forget it. But it's not necessary. So what goes on top? 84. Remember, it's 1 times c, or a times c. What's on the bottom? Negative 19. And then I have x and x. So 1x and a 1x. So what two numbers multiply to 84 and add to 8? Oh my goodness, I cannot talk. Add to 84. Multiply to 84 and add to negative 19.
Negative 21 and negative 3.
Negative 21 and 3.
You got 7. Not 7. 4 times 3 is 9. Okay, yeah, 94. 60.
That's what I heard first. So what do you have?
12 and 7.
12. Negative 12 and negative 7. So negative 12 times negative 7 is positive 84. Negative 12 minus 7 is negative 19. There is nothing to reduce, so your factors are x minus 12 and x minus 7. So if you think you have factors, make sure you go back and check. Okay, so multiply them and see if you get the top number. Add them to see if you get the bottom number. How else can I check to see that this is correct? Box or foil. And you should get this answer up here, what you started with. If you don't, then this isn't right. Or you multiplied wrong. But it's probably that this isn't right. Okay? Number 3, there is no GCF. I'm just going to do the x, but you can use the super x. Two numbers that multiply to 30 and add to 13. 10 and 3. Again, check. 10 times 3 is 30. 10 plus 3 is 13. X plus 10 times x plus 3 should be your answer. Make sure on your test tomorrow you box or highlight or something so I can find your answers. Okay? Number 4. Where should I start with number 4? GCF. What can I pull out? A 2. So if I pull out a 2, I'm left with x squared plus 14x plus 49. Okay, so I pulled out the GCF of 2. I'm going to look at what's inside the parentheses to see if I can factor any more. What can I use here to factor? The x. Okay, So if I use the x, I'm looking for two numbers that multiply to 49 and add to 14. 7 and 7. 7 times 7 is 49. 7 plus 7 is 14. I have my 2 on the outside, and I have x plus 7 times x plus 7. You can write it like that. I will also accept 2 times x plus 7 squared if you wanted to condense it, because they're both the same, but I will take either answer. Okay. Number 5. Did you see the GCF? So if you pull out a GCF of 9, you're left with x squared minus 4. And then if you factored number 1 correctly, you should be able to factor number 5 correctly. It's the same thing once you pull out that GCF. So 9 and then x plus 2 and x minus 2. Now if you look at this original problem, is that difference of squares as is? Yeah, right? You would have 3x plus 6 times 3x minus 6. But there's that GCF that you have to pull out. So make sure you check GCF first, even though it looks like difference of squares initially. Okay. Number 6, do I have a GCF there? A 2? Okay. So if I pull out a 2, I'm left with 2x squared plus 19x plus 17. How do I factor this when I have a leading coefficient greater than 1? This one's a super x. So 17 times 2 gives me 34. I have 19 on the bottom, a 2x and a 2x. So I'm looking for two numbers that multiply to 34 and add to 19. 2 and 17. 2 times 17 is 34. 2 plus 17 is 19. Reduce if you can. So I can reduce the 2's. This does not reduce, so I'm left with 2 on the outside, x plus 1, and 2x plus 17. Last one on this side. GCF?
Yeah.
An x, right? Leaving me with x minus 16. Be very careful. This is not difference of squares. Why not? The x is not squared. This is just GCF. Don't try to factor something that cannot be factored more. So all you had to do was pull out the x and you're done there.
For number 5, how can you get negative 4?
Negative 36 divided by 9 is negative 4. Okay, so this one was just GCF. Any questions on factoring? Just factoring completely. I mean, we're going to still factor, but any questions on that first column? Okay. What makes this second column different? Okay, you have to factor and solve. So you're going to set each set of terms equal to 0 to find what, and all of these are x's, yeah, what x actually equals. So before we go through this, what are some important things? What's the first thing that you have to have?
You have to have all the numbers on one side.
Okay, so what's that called?
It has to be set equal to 0.
Wait,
Standard form.
Standard form. So when it's in standard form, it will be at set equal to 0. So you'll have it in standard form and your equation will be set equal to 0. You will then factor just like we did on problems 1 through 7. And then the last part is the zero product property. Product property. Okay. There we go. Setting each of those terms equal to 0. Okay. Number 8, where should I start? Add 11 to both sides because it's a negative 11. So if I add 11, I'm left with x squared minus 49 equals 0. It's in standard form. It's set equal to 0, so now I can factor. How do I factor x squared minus 49? Difference of squares. Square root of x squared is x. Square root of 49 is 7. One's plus, one's minus. That's still set equal to 0. Okay, so that's my factored form. Now I use the zero product property. You need to show me these steps. So x minus 7 equals 0, x plus 7 equals 0. This I will allow you to do in your head. What does x equal? 7 and negative 7. Okay, but that is the work that I should see on your paper. This you can also do in your head if you're okay adding that by your, without writing it down. But you should show me factored form, and you should show me each product set, or each factored piece set equal to 0. Number 9. Are we in standard form? Yes? We're set equal to 0. So I'm just going to factor. Because my leading coefficient's a 1, I'm going to use the x. So I'm looking for two numbers that multiply to 40 and add to negative 13. Negative 8 times negative 5 is positive 40. Negative 8 minus 5 is negative 13. So in factored form, x minus 8 times x minus 5 equals 0. Set each factor equal to 0. What does x equal? 8 and 5. Number 10. Are we in standard form? Yeah, we're set equal to 0. I see a 2 out front, so I'm going to check for GCF. Is there one? No. Nope. So I'm going to go straight to the super x. 2 times negative 8 gives me a negative 16, and then I have a 15 on bottom. Two numbers that multiply to negative 16 and add to 15. 16 to negative 1, so 16 times negative 1 is negative 16. 16 minus 1 is 15. Reduce if we can. 2 goes into itself once. 2 goes into 16 8 times. So I'm left with x plus 8 times 2x minus 1 equals 0. Set each factor equal to 0. What does x equal here? Negative 8, because I'm subtracting 8 from both sides. On this one, what are my steps? I'm not going to write them out, but what are they? Add 1, and then divide by 2. So x equals positive 1/2. Add 1 and divide by 2. Number 11. Where should I start? Subtract 5. What am I going to combine 5 with on the left-hand side? Nothing. There's no like term, so I'm just going to rewrite it. So 8x squared plus 6x minus 5 equals 0. I'm in standard form. Is there a GCF? Nope. So straight to the super x. 8 times negative 5 is negative 40. 6 on bottom. Two numbers that multiply to negative 40 and add to 6. So at 10 and 4, which one needs to be negative? The 4. 10 times negative 4 is negative 40. 10 minus 4 gives me a positive 6. I can reduce. 2 goes into 8 4 times. 2 goes into 10 5 times. What goes into 8 and 4? 4. So it goes into itself once and into 8 twice. So I'm left with 4x plus 5 times 2x minus 1 equals 0. Set each factor equal to 0. Whoops. I wrote them backwards, sorry. Here I would do the same thing I did here. Right? Add 1 and divide by 2, so you get x equals 1/2. What would I do for the second one? Subtract 5 and divide by 4, so x equals negative 5/4. Number 12, am I in standard form?
Yes.
Yes? Set equal to 0, so I'm good. Is there a GCF? Nope. Okay, so how would I factor that? Difference of squares. There's two terms, a subtraction sign, and both are perfect squares. What's the square root of 4x squared? 2x. What's the square root of 25? 5. One's plus, one's minus. So 2x minus 5 equals 0, and 2x plus 5 equals 0. X equals positive 5/2, and x equals negative 5/2. $13. Subtract 7. 12x squared plus 17x minus 7 equals 0. There is not a GCF, so I'm going to go straight to the super x. 12 times negative 7 is negative 84 and 17. And then I have 12x and 12x. Two numbers that multiply to 84 and add to 17. Negative 84 and add to 17.
21 and 4.
Okay, so 21 and 4. The 4 needs to be negative. 21 times negative 4 is negative 84. 21 minus 4 gives me a positive 17. Reduce if I can. What number goes into 12 and 21? 3. So 3 goes into 12 4 times. 3 goes into 21 7. Anything go into 12 and negative 4? 4. So 1 and 3. So I'm left with 4x plus 7 times 3x minus 1 equals 0. Right?
Wait.
Okay. So 4x plus 7 equals 0, and 3x minus 1 equals 0. Final answer, negative 7/4 and positive 1/3. Last one like this. Standard form, set equal to 0. Is there a GCF?
Yes.
What? X. Okay, so I'm left with x squared minus 4. Is there anything I can do with x squared minus 4? I sure hope so, because this is now the third time you've seen x squared minus 4 on this piece of paper alone, right? Number 1, number 5, and now this one. So you should know by now that it's x plus 2 and x minus 2. Now here's where people mess up on this problem. How many answers will I have? 3. How many x's do you see? 3. You need to set each factor equal to 0. So because this is an x out here, I can set x equal to 0. I can set x plus 2 equal to 0, and I can set x minus 2 equal to 0. If this was a number like 5, and I set 5 equal to 0, is that a true statement? No, so I would cross it out and move on. But x is allowed to equal 0. Okay, so here is one solution. X equals negative 2 is another solution, and x equals positive 2 is my third solution. There could be one like that on the test, yes. Okay, so if you pull out a GCF, when you're setting it equal to 0, the number of variables that you see are going to be the number of solutions that you have. Okay. Any questions on 1 through 14? Yes, ma'am.
Would you count that off if we didn't set x equal to 0?
Yes, you would lose something. I don't know what it would be, but you would not get full credit. So my guess is if it's worth 4 points, you'd get 3 out of 4. Okay? Because you probably would have factored it correctly, giving you a point, and then each of those would have been a point. Any other questions on 1 through 14? Nope? Okay. Let's look at the back. Are each of the following solutions of x squared plus 12x minus 28 equals 0? Okay, there are a couple ways you can approach this. I'm hoping that you realize since it's set equal to 0, it's exactly what you just did on the front. And a solution is what x equals. So if I were to factor this, because it's already in standard form, what two numbers multiply to negative 28 and add to 12? 14 and negative 2?
Yeah.
So 14 times negative 2 is negative 28. 14 minus 2 is 12. So I'm left with x plus 14 and x minus 2 equals 0. How do I find the solutions? Whoops. Set each factor equal to 0. So you should have work for all these problems. If you just circle yes or no on the test tomorrow, I will mark it wrong. Okay, you have to show me some sort of work. I'm left with x equals negative 14 and x equals positive 2. So A is yes, B is no, C is yes, D is no. But I expect to see work. So yes, no, yes, no. Now, if you factor and you don't get any of these as solutions, I would go back and check your work because I'm pretty sure we made sure there were solutions. Questions on 15? How many of you understood what it was asking you for before I even went over it? Understood that you needed to factor and solve. Okay, good. What tipped you off to factoring and then setting it equal to 0? The fact that it equals 0, there's an equal sign in there. Okay, so those things should be common to you now. All right, number 16. Which of the following are solutions? So it's the same thing. The problem with 16 is what? Okay, so it is definitely not in standard form. That's where we have to start. So in order to put it in standard form, my first step is going to be to distribute that 2. So I have 4x squared minus 10x minus 2 equals 4x plus 6. What do I do to get that in standard form? Okay, subtract 6 from both sides, and I can subtract 4x, right? So I have 4x squared minus 14x minus 8 equals 0. Before I factor that, is there a GCF? What? 2. So if I pull out a 2, I'm left with 2x squared minus 7x minus 4 equals 0. I then have to factor this. So two numbers that multiply to negative 8 and add to negative 7. Negative 8 times 1 is negative 8. Negative 8 plus 1 is negative 7. So I have, I need to reduce. So 1 and 4, that one doesn't reduce. So I'm left with x minus 4 and 2x plus 1 equals 0. What am I allowed to set equal to 0?
2 or no?
Okay, so if I set 2 equal to 0, is that a true statement? Nope, so I'm just going to cross it out. So if you want to get in the habit of setting everything equal to 0, that's fine, but make sure you check if it's a true statement or not. X minus 4 equals 0 I can solve, and 2x plus 1 equals 0 I can solve. I end up with x equals 4, and x equals negative 1/2. So no, yes, no, yes. Yeah.
Do you not have to find the GCF when you do the super x?
Okay, so sometimes it'll work because of the numbers. A lot of the times it won't. So you should always do GCF first. Okay? Questions on 16? Okay. 17 does not really require a whole lot of work. I'm okay with you circling yeses and nos on this one. because you should just be able to identify. Remember, difference is squares. There should be two terms. There should be a subtraction sign, and both terms should be perfect squares. Does A follow all those conditions? 8's not a perfect square? The square root of 8 gives you a decimal, right? So we cannot use difference of squares for that one. Does B follow all the conditions? Yes. C?
Oh, yeah,
If I pull out a GCF, I have x squared minus 4. So yes, always look for GCF first. And D, no, because of a plus sign. Yeah.
For number 16, is it just the final answers that you get when you circle yes or no? Or does it count in your super X too? Like if you had
No, it's just what x equals once you set it equal to 0. Okay. All right, number 18. Factor each of the following polynomials if the polynomial cannot be factored, write not factorable. So let's start with number 1. I would just use part A. I would just use the x. So two numbers that multiply to 26 and add to 15. 13 and 2. So I have x plus 13 and x plus 2. Part B. There's no GCF. This is a super X problem. And then it's 16 and 3. Two numbers that multiply to 16 and add to 3. Are we sure? You didn't try, but you're assuming? Okay, so 1 and 16 is not going to give me 3. 2 and 8 is not going to give me 3. 3 doesn't work. 4 and 4 does not give me 3. 5 doesn't work. Plus we already did 4 and 4. So this one would not be factorable. Part C. Do you see anything wrong with part C? Not in standard form. So it should be 3z squared plus 20z plus 12. Make sure it's in standard form. Do I have a GCF? No. Super X, so what's that? 36 and 20. 18 times 2? 18 times 2 is 36. 18 plus 2 is 20. I can reduce. So I'm left with z plus 6 and 3z plus 2. Yeah.
Okay, so I put X here.
So like I said before, I'm not going to mark it wrong if you have the wrong variable, but you need to be cautious of it. Okay. All right. Last problem. Determine whether each value of c makes x squared minus 5x plus c factorable. If so, factor the polynomial. So all you're doing is taking c and plugging it in. So this first one would be x squared minus 5x plus 36. Can we factor that is what it's asking. Are there two numbers that multiply to 36 and add to negative 5? We're for sure that's a no?
Yes.
Everyone agree with that? Okay. But what if C is negative 36? Are there two numbers that multiply to negative 36 and add to negative 5? How about negative 9 and positive 4? Negative 9 times 4 is negative 36. Negative 9 plus 4 is negative 5. So x minus 9 and x plus 4. Any questions, comments, or concerns about the practice test? Okay, so the test tomorrow is 12 questions with an extra credit problem. Okay. The front looks just like the front on this page. And then the back looks very similar to the back. Just everything's shorter. Okay, so you need to understand what solutions are. You need to know the 4 different ways to factor. You should always check for GCF first. And then I will tell you for the extra credit problem, you will have to factor multiple times to get the final answer, but it is not something that you can't do if you kind of just plug through it. So you're going to have plenty of time to attempt the extra credit tomorrow. And I would definitely take advantage of that because it's a more challenging problem. It's worth more points than most extra credit problems would be worth. Okay? I haven't graded it yet, but it'll be worth. Normally they're about 1 or 2. This one will probably be closer to 3 or 4. So, any questions? We think we can factor and do okay tomorrow? All right.